So welcome to my talk. Thank you all for coming and choosing me over whatever is on the other track. So the title of my talk is a quick look at macOS thumbnails. So this is basically a very high-level overview of centralized thumbnail caches in macOS. So first of all, let's say a couple of words about who I am. So I'm a fourth-year student of cybersecurity and forensics at Napier, and the research that I'm showing today is actually my dissertation project. So it's due in a week. I'm very happy to be here. Maybe a couple of words of how I got here. So a couple of years ago, I attended a Django Girls event. I made a blog. I was very excited about making something that works. And then I started mentoring at other Django Girls events. I started organizing some other Django Girls events. I got involved in the Python community. Then for some reason, I don't remember why, I applied for Edinburgh Napier to study cybersecurity. And I quickly joined NUSEC, where I started just going to all the meetups that are, all around Scotland, all the conferences. And then last summer I interned at ZoneFox, and now I'm here, and I will hopefully graduate soon in May, I think. Let's keep our fingers crossed for that. Okay, so what are thumbnails? Probably most of you know thumbnails are just the miniature little images of that represent the files made by your operating system. They are there to help you navigate your files, because if you were just supposed to remember what your files are, but just by the thumbnails, we all know that we just call everything FD, FD, FD. So you need thumbnails, right? So what's interesting, thumbnails as far as I'm concerned, most mainstream operating systems right now, they are not only made for image files, as you would think, but for many other files like code, text editor files, PDFs, images, videos, obviously, and a lot of different ones. So in macOS specifically, the technology that the mechanism of making these thumbnails is called QuickLook, and it's also responsible for that cool feature that you can just select a file and then press the space tab, and then you can get a full preview of, for example, if it's a PDF of a couple of pages, you can scroll through these pages, you can read it completely fine, but it's not actually opening the file, it's just a quick look at the file. So just before we continue, this talk is only about macOS. So if you are interested in Windows and Linux for comparison, or just to learn something new, you can scan this QR code. If you have an iPhone, just open your camera and point it at this, and it should take you to a link where I put up some resources. And so if you are interested in Windows and Linux, go do that. But today I'm only talking about macOS. So what are thumbnail caches? They are basically directories, and you will have a separate directory for each user. So that's important because it turns out that when you're root, when you're admin, you can access all the other standard accounts caches from your account. So that will be useful later, which I'll get to that. Anyway, where is this cache? So you go to var folders, then you go there will be a random 2-letter string, a directory name, then there will be a random long string, and then there will be a C directory and com apple quick look thumbnail cache. So the best way to find it is just to go to var folders and use the find command with the name thumbnail cache from there, because you will not be able to, there will be a lot of different random 2-letter string and random long strings directories. So to find it, just use the find command being in var folders. So I'm not sure how visible that is, but it's just a directory within many other different caches there. And within that directory, we have from 3 to 7 files, because there are some additional SQLite files being created. So you can see the ones that we are interested in the most is the index.sqlite database, and another one that's important, it's thumbnails.data. So index.sqlite is a database which has all the metadata about files that thumbnails are created for and about thumbnails. And thumbnails.data is just raw data, the thumbnails themselves just in a big data blob. And it would be really difficult to parse thumbnails.data without having the index.sqlite, because all of these images are in PNG format, but they are stripped from file signatures, so you can't really carve it out easily. That's why you need the index.sqlite, where you have the offsets, and then you can easily find where your thumbnails are. So let's take a look at index.sqlite. So again, there's 5 tables inside that database: files, pending, secure, delete, buffer, preferences, reserved buffer, and thumbnails. And again, we're most interested in files and thumbnails. So let's look at both of them. What's the structure of these? And first, the files table gives us some juicy data. So we can see the path. So it also often includes volume name. So the path to the original file. So in the files table, we see information about the file. So by the file, I mean the original file that the thumbnail was made for, not just the thumbnail. So then file name, obviously, and then FSID, which includes volume ID, and then a full stop, and then a file ID within that volume. So I will show you examples in a bit where you will be able to see that in practice, let's say. And then in the thumbnails table, there's a lot fields. A lot of this is used to be able to locate where the thumbnail is within the data blob. But the ones that we are interested in from a forensic point of view is the number of times the thumbnail was accessed. So that's the hit count, and the last time the thumbnail was accessed, so last hit date. So obviously that can give us some insight in what was done on the machine. So let's think of like, how does the thumbnail end up in the cache? So like, we go into the cache, we view the database, and we see some files, but how did it get there? What do you have to do to make a file, like make a thumbnail for itself? So basically, every time you see a file yourself, so whether it's on desktop or it is in a folder and you open it in Finder, every time you actually see that file and you see the thumbnail for it, it will be created. And also, if you open a folder which, for example, has 300 images, then the thumbnails will be made for all of them, even though you'll probably see maybe 10 only because of your window size. So actually, all my experiments were done on a very, very not powerful VM. So if I opened a file, sometimes it would take a couple of seconds for the thumbnail to be created. So for example, I had a picture and there was only like this white page, let's say thumbnail placeholder. So it would take a while for the thumbnail to actually get produced. And if I was quick and just collected the cache before it, then nothing would be there yet. So basically, when you see a thumbnail, it means that it got cached there. So let's look for at a couple of examples. So for example, here I have a very, very easy scenario. I have 2 folders, and both of these folders are on the same machine. So it has nothing to do with networking or anything. There is a folder called files, and there are 2 files in them, to copy and to move. I'm taking the to move file and moving it, dragging it to new folder. And then I'm collecting the cache and looking at the index.sqlite. So when you look inside index.sqlite, you can actually see 3 records. And you remember we only had 2 files. So in the file name, we can see that there are two entries for to move. One is in, when you look at the folder part, one is in files, one is in new folder. So there are 2 separate entries, even though it's the same file that we have moved. But when we look at the file ID and FSID, where we have the volume ID and the file ID, these are the same numbers. So you can easily link them together and see that this is the same file, just has been moved somewhere else. So example number 2 is when you have an external device and you are moving a a file from the external device to your machine. So here I have USB storage, just a USB stick. There's a very important secret image called hacking JPG on it, and I'm just dragging it on the desktop and then looking at the cache. So here still the file, I have two entries and in the cache, and both of these, obviously the file name is the same, but the thumbnail can be the same for two files always. But you can see that the file IDs are different. Both the volume ID and the file ID is different because it has been moved from an external device, so it wasn't just an operation on our machine. Third little example, renaming a file. We changed the file, we changed the name of the file. I literally took a screenshot. If you have a Mac, it just gets saved with this weird name format with the date and the time when it was taken. And then then I changed the name to name changed. Again, two entries, and you can see that the file ID, volume ID, and the file ID are the same. Here, that's an interesting one. What happens when you delete a file? So here I just created two TXT files because based on my research, they also produce thumbnails. I only put test string in it, so you can't see it. But if you zoomed in really, really precisely, you would see that actually the layout of the document is reflected by the thumbnail. So you can kind of see, if I had a Word document with a huge picture, then you could see it in the thumbnail. So it does give you some information about what's inside. So I have two text files with test string in them. Then I put them in trash. And then I click on the trash, open the trash, and click empty trash so that it's super deleted, right? So then I go to the cache, and what it actually did was create yet another entry in the cache for each of the files, where you can see that the folder bit says that it's desktop first and then trash. So if you want to be extra careful and you go into the trash and delete the contents, it only increases the footprint of that file in the cache because it creates yet another thumbnail. So don't do that if you don't want to be exposed. Okay, so why do we care about this at all? Why are we looking at the cache? So first of all, it's quick and fast to copy because it's quite small. In my on my test environment that I have prepared, which isn't very powerful, it was only growing up to 500 megabytes. And when it reached 500 megabytes, it would just reset back to the start. So it would just, I know it's weird. I also thought that maybe it would intelligently switch things around, but no, it just deletes itself and starts at 0 megabytes again. So anyway, that's just half a gigabyte. It's quick to copy especially when you appreciate like how much insight it can give you into what the user has done on that's what digital forensics is, by the way. It gives you very, very useful insight in what the user has been doing on the machine. So obviously, it's much better than if you have a machine with a huge amounts of data. Then it's much faster to just go through the cache first. Even if it's just for triage, you can still do it much faster than try to check every file, especially when you're interested in what was done recently on the computer. And also, a regular user probably wouldn't think to delete it. So you would first, like a regular user would first just try to delete things, just put them in the trash and then empty the trash, maybe, if they are super smart, but they probably wouldn't think to go and delete the cache. So obviously, it's not very surprising that people started researching and thinking what can be done with this. So this is very important addition to this slide. So in 2018, a security researcher called Wojtek Reguła has published a blog post about how the cache can leak information from your encrypted drives. So this is another QR code to that blog post if you want to take a look at it. So he basically realized that when you plug in an encrypted, password protected drive to your computer, and then view the contents of it and then eject it and take it away, the thumbnails will still persist in the cache even after it's ejected. So obviously that's a huge security concern. So obviously a lot of people were interested in it, and the guy is just like a master's student in Poland, but it got a huge coverage in different like Hacking News and Tech Radar, all these security blogs. You can see there's a lot, and also security forums. So obviously there was a lot of pressure on Apple to do something with it and fix it somehow in the next operating system version, which was Mojave. So what did they do? They just included the thumbnail cache under their system integrity protection. So it means that basically you cannot do anything with that file. So you go into the cache and you have different caches, and some of them, including now thumbnail caches, is just inaccessible to you. You cannot copy it, you cannot delete it, you cannot move it, you cannot run file on it to see what it is. Like you have no permissions to do anything. So there is a way to kind of bypass it, because the system integrity protection can be turned off. You can just boot into safe mode and disable it from the terminal there. So then you just have access to the cache and you can analyze it, as I have shown before. And even though they have fixed the encrypted drive vulnerability, so now when something's encrypted, you plug it in, you view the stuff, it doesn't get saved in the cache. Still, if you plug a USB stick in and you plug it out, which isn't password protected, not encrypted, then it persists. Still, if you are sharing a folder within your network, then it still gets saved and persists there. So deleted files still stay there. So it's only this one thing that they thought of, but nothing else. So hence this slide. So you may think, okay, so how is that useful? Because I just told you that they have made this system integrity protection on this directory, so you are not able to access it in any way. Well, what you really need is the root password, because after you boot into safe mode, you need to reboot and then access obviously the root account again. So there is a number of scenarios where you actually do have access to the root account. For example, when it's your machine. So if you are an employer and or for example, a university, anytime it's your machine, and you can still you can do all of these things as long as you have the main control of it. Another thing, you could also think about it in a way that you can trick a person to use your computer and then be able to reconstruct their behavior based on the cache. So I have a couple of two real life examples of this working. So I have read many different court cases while working on my dissertation to look for something that would kind of touch upon this topic. So what I found is that the approaches to the thumbnail caches, and also in general to digital evidence, but thumbnail caches in particular, they differ greatly because of lack of kind of standardized and well-researched knowledge about how they work. So instead of treating the fact that there is something in the cache as evidence that, for example, you have viewed or whoever is being charged viewed something indecent, for example, on their computer, they treat it as possession or making of this indecent contents. So, for example, if there's first case I'm going to talk about is Regina versus Porter. So there's a case number on there. You can take a picture and Google it later if you want. So basically, in both cases that I'm going to talk about, these are men who got charged already with possession of indecent images. And in this case, the guy had over 3,000 thumbnails were recovered from his computer showing some indecent content, and he then appealed to around 2,700 of them were recovered using a special software, which was kind of lent to the UK by the US government. So he appealed the charge and said that because you needed the special software, the contents were not available to him, because he wouldn't be able to see this 2,700 photos, because they were only available because obviously he deleted them at some point before. They were only available using the specialized software, and he actually did actually get, like, his appeal was granted, and he was found not guilty. He was found guilty of possessing other ones that were easily accessible, but this one, but it's like, it seems funny, but when you think about the difference, if he had like 800 or, over 3,000 indecent photos, then it's a different kind of magnitude of a crime, right? So he actually won that little bit, and they did say, okay, it wasn't accessible to you because you would need that special software. On the other hand, though, there was another case, Regina versus Christopher Brown, where the guy was found, he appealed his charge as well. And he said that the fact that the thumbnails were on his computer were because he has downloaded them, and he said that he did not view the pictures at all. So this is, again, if there was standardized and well-researched knowledge about how the thumbnail caches work, then obviously that could be proven untrue, like basing it on whatever operating system he was using, because you need to view the file in order for the thumbnail to be made. So he did not have his appeal granted, because the jury and the judge have found that the thumbnails were big enough for him to be able to enjoy the content anyway. So he was found guilty. But you can see these two cases are very similar, but still, still there were two very different approaches. And I just find that it's really weird that no one is actually treating thumbnails as evidence, which is basically what it is, more than actual possessions of illegal content. Okay, so that's the end of my talk. Thank you very much. I won't be taking questions here, but if you have any questions, please tweet me or ask me in the pub later. And all the resources and the slides later will be published on my blog, and this is a QR code for it. So thank you very much.